All right, here we are for Unit 4.06. So lots of stuff that we're doing today. Our aim is to identify the symmetry and periodicity of trigonometric functions given the graph or algebraic representation of the function and explain these characteristics using the unit circle. A lot going on here. Want to call our attention to the word graph, and basically we're trying to look at the graphs of our trigonometric functions that we've talked about and kind of look at some of the characteristics that they have. Okay? To start us off, I want to go back to the Ferris wheel that we looked at the very beginning of the unit. And I want you to sketch a graph for the height of the Ferris wheel cart above the ground over time. So if I have a graph, the x-axis will be time, and the distance above the ground is the y-axis. Go ahead and do that right now. Alright, so hopefully what we thought about is, it starts somewhere above the ground, it works its way up, it comes down, it works its way up, it comes down. And it looks as though it's some sort of graph which is going to repeat itself. Okay? And this led us to think about what functions we know that repeat values, and we've realized we don't have any at this point. And so this led us to think about a circle, and the fact that if I follow a circle around and around and around, I'm going to eventually repeat points. And so this led us to really dig deep into the circle, and we realized that we can consider any circle because as we move around and around the circle, it doesn't matter how big the circle is, the angles will always be the same. And so we thought about a unit circle, and we realized, we defined the point on the unit circle given some angle theta, depending how far around the circle we turn. We said, okay, the x value is the cosine of theta, and the y value is the sine of theta. And these are the points that are going to repeat, right? As I move around the circle, eventually the x value is going to be the same again, and the y value likewise. And so now we can actually think about graphing each of these functions. So the first thing I want you to think about is, what does the cosine depend on? In other words, what information about, what information do you need in order to determine the cosine? Hopefully you realize, you paused the video and thought about it, that in order to figure out the cosine, it depends on the angle, right? The angle theta is what the sine and cosine depend on, right? I can't tell you what the point on the circle is until I know what angle I'm referring to, right? How far I've turned. That will determine what the point I'm looking at is. So if I go to graph cosine, the independent variable, the thing that I need to know in order to say the value of cosine, is in fact the angle theta, how far I've turned. And then I can say what the cosine of theta is. So let's just take one example. Let's say this is the point pi over 6. What's the cosine at pi over 6? Well, it's the square root of 3 over 2. And the square root of 3, it's a little less than 2, so this is going to be a little less than 1. So if I think about 1 being right here, the point on the line is going to be somewhere here. Okay. All right, so now that you have that little tutorial, we're going to move on and we're going to actually try and sketch the graph ourselves. Let's start with cosine. You have your unit circle out in front of you, hopefully. I've pasted one in here in case you are missing it. And we have here a graph. I want to graph cosine first. So the x-axis, of course, is the measure of theta, and our y-axis is going to be the actual measure of cosine theta. And what I want you to do is go ahead and pause the video and sketch the graph going all the way to 3 pi on the right and to negative pi on the left. And then go ahead and press play, and we'll talk about it once you've finished. Right. So what I want you to do is I now want you to create a new graph. Okay, so whatever yours looked like, that's great. I'm going to look for that. And now what I want you to do is go ahead and create a new fresh graph so we can discuss and make sure that you have a really clear visual. So we are dealing with cosine, so I'll stick to the color that we have. And let's just think about the first point. So when theta is 0, right, when I haven't moved anywhere, the cosine is 1. All right, and then moving on, we have theta is pi over 6. That's the next value that we've got. And now remember, there are values in between, but we can't really compute those very well. It would take us quite some time. So we're going to move on to the next easiest one that we have. And so pi over 6, and I'm actually going to make a little table here just to help us out. So when theta is pi over 6, we have square root of 3 over 2. And I encourage you to go ahead and actually figure out what that is. Square root of 3 over 2 is going to be about 0.866. And pi over 6, well, think about it. Here's pi, so if I split it up into 6, so this is half, and then each half would have to have 3 pieces. 1 piece, 2 piece. So 1/3, 2/3, 3/3. So 1/3, maybe about there. Okay. And again, it's a little hard to see. Let's use this. All right. Here we go. And then we have pi over 4. And that's the square root of 2 over 2. And that's about 0.7. And now pi over 4, that's right here. And 0.7 maybe is about there. It's a better point here. Okay. And then we have pi over 3. And pi over 3 is 1/2. And so pi over 3, well, if I split this up into thirds, so this might be 1/3, 2/3, 3/3. All right. And then we have pi over 2, which is half of pi, which is right there. That's going to be at about, that's going to be exactly 0. So if I start connecting, there we go. Okay, so we'll see what happens. Let's keep going. So now I have 2 pi over 3. Let's think about what 2 pi over 3 is. So I am 2/3 of the way to pi. So if this is 1/3, 2/3 of the way, and that is going to be negative 1/2. Okay. And then we're going to keep going, and I encourage you to pause the video and just do this on your own, and we'll go a little bit further. When I get to 3 pi over 4, so that's 3/4 of the way to pi, so that's right here, I'm going to be at negative root 2 over 2, which is negative 7.07. And I'm going to keep going. 5 pi over 6, I'm pretty close to pi now, and that's going to be negative root 3 over 2, which is negative 0.866. And then finally I get to pi, and pi is exactly negative 1. Now what I want you to do is I want you to pause the video and I want you to try continuing on your own at least to 2 pi. And I'm going to give you a chance to do that, and then we'll come back and discuss. All right, so now that we're past pi, we're thinking about 7 pi over 6. And the key to think about this is if this is pi, right, this is 1 pi over 6 more. So it's a sixth of the way to 2 pi here. So I'm really just thinking about the same thing that I did back here. So pi over 6 past pi, right, I'm going to be back again at negative root 3 over 2. Okay. And kind of continue my line here. All right, and then 5 pi over 4, so this is a fourth of the way now here. I'm at negative root 2 over 2, so that's negative 7.07. And then I keep going at 4 pi over 3, so that's a third of the way, so now I'm about there. And that's exactly negative 1/2. Okay. And then I get to 3 pi over 2, and that's exactly a half of the way to 2 pi, right? Think about it. Here was pi, here's 2 pi, and so I'm half of the way to 2 pi, and that's going to be 0. Okay, we're going to keep going. At this point, I'm going to pause the video and let you finish it on your own. Go all the way to 3 pi if you can, and I'll give you about 15 seconds, and then the video is going to skip to where the graph is finished. All right, so here's the completed graph of cosine, all the way from the left to the right. And notice how this repeats itself. Okay? Where it might have seemed a little tricky is what happens after 2 pi. Well, think about it. You're just following the points looking at cosine all the way around the circle. After 2 pi, well, what comes after 2 pi? Think about pi over 6 past 2 pi. All right, so that'd be 13 pi over 6, and that would be at right here, at 3 pi over 2, so that'd be 8.866, and then I'd keep moving. I'd have be a fourth past 2 pi, so I've already made one revolution, and now I'm a fourth past, and that would be 0.707, or root 2 over 2, and then finally I move pi over 3 past, and I'm at about 1/2, and then pi over 2 past, so I made one full revolution and pi over 2, and so that's going to be at 0, and I'm really just continuing to follow the pattern, right? Once I've moved 2 pi over 3 past the first revolution, I'm at negative 1/2 over here, and then negative root 2 over 2, and then finally negative root 3 over 2, and then finally negative 1. And so this is the graph of cosine of theta. What I want you to do now is pause the video, go ahead and graph sine of theta. And what I will do is go ahead and graph it, and then what I'm going to do is actually in about 10 seconds skip to the full graph of sine of theta, and you're going to go ahead and check your work and make sure that you did it correctly. So graph it first on your original graph where you tried graphing cosine, and then once you've worked out your issues, make sure you have the graph compared to cosine of theta on this new graph that you've created. All right, so here's what sine of theta looks like. And just to give you an idea of how I went about that, I thought about sine of 0, which is the x-coordinate, or the y-coordinate, which is 0. And then moving along, it starts to increase, right? It starts to get bigger and bigger, 1/2, then root 2 over 2, then root 3 over 2, and then finally, once I get to pi over 2, I'm at 1. And then it starts to decrease again all the way back until I get to pi where it's 0. And then I keep going. It will decrease and decrease and decrease. Finally, it will get to negative 1. down here. I should make sure I add that. It's -1. Good. And so we'll get down to -1, and then finally back to 2 pi, where it will be 0, and then I will continue past 2 pi, right? So this would be 1 full revolution, and then it's continuing on and continuing on. If I think about going counterclockwise, right? As I move counterclockwise, it's getting negative, 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 negative until it gets to -1, and then at -1 it starts to increase, 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 increase until it gets to 0, and then it continues increasing, right, as I get to +1. And so hopefully this is a pretty clear picture of how cosine and sine are changing as theta is changing, the angle that is opening up. Okay, so on the next page you're going to see some questions. Those questions are going to be our discussion tomorrow. So you are going to need to have question or answers written down. So let's go ahead and look at those questions. They're really not a whole lot. So just take a look, use these questions to analyze, use the graph to answer these questions, analyze the graph. After you've done these questions, the big piece that you want to really think about is answering this question. So what I'm looking for are answers to all of these, and then finally an answer to this big question about the unit circle.